Right, okay, so what do we have today? We have the precedence graph. What is this? Okay, so the precedence graph for a schedule is defined as follows. It is a directed graph, okay? Its nodes are the transactions that occur in S or the transactions that occur in S. It has an edge from transaction Ti to transaction Tj. Okay, if there is a conflicting pair of operations, so there is a condition if there is a conflicting pair of operations, otherwise there would be no edge. And of course, these conflicting pair of operations in the schedule S have to be, number one, operation A appears before operation 2 in S. Operation 1 belongs to transaction Ti. Operation 2 belongs to transaction Tj. We will understand what this stuff mean in a second. Okay, so what does this mean? Right, so let's have an example. Of course, this is an example we have here. It's defined beforehand. So, of course, but we can make a new example. Just to save time, we have this already here. Okay, so highlighted here, we have, as you can see, we have 3 transactions because apparently we have the number 2 here, we have number 1, and we have number 3. We don't have number 4, so what do we do then? We say, okay, since we have 3 transactions, okay, we have 3 transactions, then we need 3 nodes, and of course, there we go. Here we have them 3 nodes, okay? And then what we need to do next is identifying conflicting pairs where, this is a where thing, okay, where operation 1 comes before operation 2. So this predicate or condition has to be satisfied. Right, so let's start actually, let's start identifying the conflicting pairs. Starting with the first transaction, which appears to belong to transaction 2. Okay, so we see, first of all, if you want to revise conflicting pairs, just please Google it or see my videos if there is any on conflicting pairs. Okay, right, so we have R2 on X. So what are we interested in? We are interested in the element X because in order for a conflict to happen, it has to be on the same element and also has to be on different transactions, i.e. it cannot be on transaction 2 because we are here doing on transaction 2. So if it is a conflict, then it has to be either on transaction 1 or on transaction 3. And of course, a conflict cannot be on 2 read operations. It has to be, it has to include 1 write operation. So it can be 2 write operations, it can be 1 read, 1 write, but it cannot be 2 read operations. Okay, so moving on, of course we skip the second part, which is our read 1 I y, sorry, we don't want this, so we don't care about the second. Let's see the third. Is it reading on X? Yes, but it is the second transaction, so we don't care about it. Let's see read 2. Of course we don't care about read 2 of Y because this is also a read operation. Read 3 of X, again a read operation. Now we are reading W1 of Y. Again, we don't care about it because the element is not the same. We go for the next, which is W3 of X. So there we go here, right? Of course, again, just to explain, we went through all of these and none of them satisfy the condition of conflicting pairs, therefore we skipped them. Okay, this is why we actually are here right now. Right, so W3 of X. So what the hell is this? Let's have a look. So this is from 2, as you see, from transaction 2 to transaction 3. Yeah, so what do we do then? We simply bring an arrow and say, okay, you are conflicting. Okay, and of course this is why we have an arrow to the direction of T3 because it's a directed graph and it is going from operation 2 to operation 3 in a sense, if you will, if you want to say it or if you want to look at it this way. Anyways, let's move on. Right, so let's carry on to this operation. Of course we don't consider it because the element is Y and we are looking for the element of X. Okay, so we are done with these babies, so we tick them. Okay, then what we do is we see this baby and compare it with all other operations as we did with read to on X, yeah? Okay, so what we say is we are looking for an operation that reads the element Y. So we skip this, and we skip this because it's a read operation. We skip this. Okay, and also we skip this because it's the same transaction, which is 1. Although it's the same element, but it's a different transaction. And finally, where do we land, you think? Where do we land? We land in here. Why do we land here? Because we have a read operation and a write operation. They are from different transactions and they are reading the same element. So this is a conflict. So we say, okay, it's from R1 to W2. What we do is we simply say R1, which means belongs to transaction 1, and W2 means belongs to transaction 2. So we draw this beautiful arrow here. Okay, and what we do is we take this baby and we take this baby. Okay, now we go to W, which okay, we go to write to on X to be more precise. Okay, so write to on X, right? So of course we skip this baby. We skip only this baby, actually. Why do we skip this baby? Yeah, well, yeah, we skip this baby because it's reading Y, which is something we're not interested in. Now we go here and we see that this is a read 3 on X. Yeah, so it satisfies the condition, but what we have is we already have an arrow in this direction, yeah? So we have this arrow already. So do we draw another arrow? Of course, no. What do we say? We just say, okay, it's already there. Of course, you don't have to write it's already there, but this is, you know, some boring details. Well, others might look at it as useful details. Anyways, let's move on. Okay, so we are reading this baby. Of course not, because it is reading the element Y. We don't care about it. Then what we do is we right, let's have a look. We see this thing. Okay, so this is W3, yeah, W3 on X, so which satisfies the condition. But do we have from 2 to 3? Yes, also we have from 2 to 3. So we just say it's there already. And then we go to W2 on Y. Of course, we discard this because it's reading Y. Right, so we are done with this. Yeah, so what do we do then? We go to this. We are now comparing Y. Okay, so let's compare Y. Okay, we compare it again with why don't we compare it with these, you think? Yeah, we don't compare it with these because we have to say operation 1 appears before operation 2 in S. Yeah, this is why we don't compare it with these. So we start the comparison. Of course, this is not accurate, but kind of, you know, for the video, I guess it makes sense. Okay, now we start comparing from here. Yeah, so let's see what we do. Okay, so we are reading on Y. Let's see Y. Of course, we skip this because this is X. This is Y. Okay, beautiful. So this is from R2 to W1. They are both reading on Y. So what we say is we have an arrow, draw it like this, okay? And then we say, right, this is it, this is it. Now we come to read 3 on X, this baby. Okay, so let's compare it. Of course, this is why we skip it. This is the same transaction 3, we skip it. So let's skip this baby, and this is why we skip it, yeah? The last one. And then we go W1 on Y. We compare it only with elements that come after it. So we compare, it's not valid because it's not valid. If we compare this with this, Y and X do not satisfy conflicting. Then we go W1 on Y and W2 on Y, and we find that this is already there, yeah, which is this thing, yeah, it's already there. So what do we say? We just simply, for the boring details, we say it's already there, and then we say here it's already there, yeah. So now we have actually successfully constructed our very beautiful diagram, yeah. Is it diagram? It is a precedence precedence graph, not a diagram. Anyway, but you can call it whatever you want. So this is our precedence graph for this schedule. Yeah, I hope this makes sense. If it doesn't, no problem. It will make sense maybe at some point in the future. Okay, see you later, alligators.